We are going to talk about weather generators that will use weather regimes, and it has a like, but before that, that's just about like resampling the historical data to generate weather. But we are going to use weather regime based weather generator, which will be more accurate, and it's easier to like make it based on the region. Weather is just different variables like precipitation, wind, temperature, etc. So it's a time series which is like dependent on the last one. For example, tomorrow's temperature will probably depend on today's. So if we just take a random sample from all the historical data, even though we did generate a weather, it's less likely to happen if it just joins maximum and minimum one after another. So even though we can take multiple random sample, like it will still have a little bit of jagged effect. So to we can use lots of other methods to smooth it out, but this one, like, we are going to use weather regime based weather generator that will take into account the pressure anomaly and make precipitation and temperature based on that. To calculate the pressure anomalies, first we have to get the geopotential height data. We can get that from NSAP reanalysis 2 in this case, and then we have all the time series of pressure anomaly, like pressure data, which we are going to use, and then we are going to average them. After averaging, we get a single raster, and by subtracting the average from all the daily values, we'll get the pressure anomalies, which looks something like this. They have like patches of high and low values of anomalies that we can use to cluster together into weather regimes. Now we need to just convert it into time series data. Like normally time series data is just like some points, like temperature or something, but right now we have a like pressure anomaly, that's raster of data, that's like a matrix of certain row by column. So we just need to convert them into like single discrete number. That would be the whichever weather regime that anomaly depends on. We can use simple algorithms like nearest neighbor, or like k-means clustering, or any other method to just convert them into like individual weather regimes. After that, we can just group the same weather regimes and like how long they are running in a session, and then when they started. After that, we can calculate probabilities and other stuff which we can use to simulate the regime.